Okay, this is Geometry Notes 3.8, slopes of parallel and perpendicular lines. Today's objective, to relate slope to parallel and perpendicular lines. So we're going to do slopes of parallel lines first. If two non-vertical lines are parallel, then their slopes are equal. If the slopes of two distinct lines are equal, then the lines are parallel. Okay, those are converses of each other as we look at it. Any two vertical lines are going to be parallel to each other, and any two horizontal lines will be parallel to each other. So keep that in mind. By definition, the horizontal lines are easier because their slope is 0. Vertical lines, they're undefined slope, so that might be a little bit more of a challenge to remember. But now let's find the slope of these two lines, L1 and L2. Okay, L1 slope. So I'm going to stack my points, 5, -1, -4, 2, and find their difference. That's 9 over -3, which is -3. I'd like you to find L2. Turn off the tape and go ahead and do so. Now you're finding L2. Again, stack your x's and y's, your y's over your x, and step your y over the x and find the difference. And then we have 7 over -2. Now since these two slopes are different, the slopes of L1, which is -3, and the slope of L2, which is -7/2, are not equal, so L1 is not parallel to L2. And if you look at these a little bit more closely, if you kind of check these out, these are a little wider down here than they are up here, but we have actual proof that they are not parallel. The slopes would have to be the same for them to be parallel. Okay, so now find the slope of the line parallel to the given line. Okay, so these are in y equals mx plus b form. So the slope of this line is 5. So a slope that's parallel to this line would be 5. M equals 5. That's a slope parallel to the given line. I am not interested in the y-intercept. I only want the slope. And once I read the slope, I'm done with the line. So let's read this slope and go ahead and fill it out. And hopefully you got -3 as their slope. Now in C, this might look a little weird compared to the others, but it's a fraction. And the slope is -3/4. So now, again, read the slope from your equation provided and then move on. So here, writing the equations of parallel lines, write an equation of line parallel to y equals -3x minus 5 that contains the point -1/8. So the slope, read the slope, -3x. minus 5. So -3 is what I've read, and now I am done with that equation. Okay, now that I have slope and I have a point, I now can pop it into y minus y1 equals mx minus x1. This is point slope form. So I pop my 8 in for y, my -1 in for x, and -3 in for slope. I evaluate it, getting rid of my, I should say simplify it, getting rid of my negative signs. But this is point slope form, and this is an equation, and since I had you writing an equation of line, that's good enough for this question. But what if I wanted you to write it in slope y-intercept form? So if I wanted that, you got to solve for y, which means you got to distribute the 3. Okay, and then you got to add the 8 over. And now I've got y equals -3x plus 5. Now this is slope-intercept form. Now it's your turn. I want you to pretend that this equation, first of all, was point-slope form. Then solve for y and put it in slope-intercept form. Go ahead. Now you should have gotten that slope is -2, and again, get rid of this. We're done with that. Okay. As you went through, you went y minus y1 equals m times quantity x minus x1. That's point slope form. And this is y minus 3 equals -2x minus 0 because that's 0, 3. That's point slope form. I'm done. But what if you recognize something? You could have totally taken this and solved for this next thing, but do you see that 0, 3? 0, 3 is actually a y-intercept. So hey, 0, 3 is a y-intercept. So that means my slope is -2, my y-intercept is 3, okay, because the y-intercept, your x value is 0. I can now just pop it in y equals mx plus b, which is y equals -2x plus 3. Now, I could totally solve this for y and still get this equation. And if you didn't notice it, it's not a bad thing, but just keep in mind there are nuances to these things. If you start recognizing things, the more often you do a problem, you can use those shortcuts. Now, in C, write an equation of line parallel to y equals negative x plus 6. Again, negative 1 is my slope. I pop in my point here. Excuse me, we got to get rid of some stuff. Oh, let's not pay attention to this. Somehow I didn't erase something earlier. Okay, this is me point slope form, so I pop things in. I've got negative 1, x plus 2. Okay, as I pop those things in, and now I'm just going to solve for y, and I get y equals negative x plus 2, and I get my slope-intercept form. Okay, now, if I read, again, slope, same thing, your turn. Go ahead, do this one, read the slope. Use point slope form, get it done. And I'll put that in there. Slope is 7. Y is negative, y minus y1 equals m times quantity x minus x1. Y minus 3 equals 7 times the quantity x minus 2. Now, if I wanted to solve and finish it out in slope-intercept form, I would just distribute my 7, add my 3, and I'd be there and done. Now that's parallel lines. Okay, that's all I've got for parallel lines. Let's go on to perpendicular lines. Perpendicular lines. Again, when two non-vertical lines are perpendicular, then the product of their slopes is negative 1. If the slopes of two distinct lines have a product of negative 1, then the lines are perpendicular. Any horizontal line and vertical line are perpendicular. Keep in mind, any horizontal line and vertical line are perpendicular. So that's the way they're defined, okay? But the product of the slopes, keep in mind, if I have two slopes and their product is negative 1, that means they're going to be perpendicular. Okay, so that's kind of a nice check, or we'll talk about them as negative reciprocals. You know, flip them and we'll take the opposite of whatever it is. So let's find the slopes, okay, of the two. Go ahead and find those slopes. Turn me off to find the slopes, and then we'll check them. Okay, welcome back. And just like we did before, the slopes, okay, stack them, find their difference. And I've got negative 3 halves, stack them, find their difference. And I got 6/9. Well, gosh. That's not the same. Oh, wait, I can reduce that. So that's 2/3. Okay, that's 2/3, which is a negative reciprocal. You flip this and take the opposite and you get 2/3. So that's kind of cool, but let's do the original check. If I have two slopes and their product is negative 1, then they're perpendicular. Well, the product of these two slopes happens to be negative 6/6, which is negative 1. So I know that the two lines are perpendicular because the product of the slopes is negative 1, okay? Just by the rule that we followed up here. Well, it's our turn. Let's check this out. A shortcut. Now remember, I've still got to read these equations, and I'd like to point something else. This is exactly the same questions that you did on the parallel page, except these are perpendicular. So I'm using the same stuff. I'm not doing anything fancy here. So the first thing we're going to do is read the parallel line. We did this already. We read the parallel line all the way across, no problem. Once you read the parallel, recognize that we are asked, find the slope of the line perpendicular to the given line. Well, once we got the slope read from the lines, we now have to take the opposite reciprocal. Opposite and flip it. Okay? Reciprocal of negative 3 is negative 1/3. Take its opposite, it's 1/3. And the reciprocal of negative 3/4 is 4/3, and that's me positive. Look at that. So these are the slopes of the perpendicular lines to the given line. Now, once I read the slope, I'm done with the line. Okay, so keep that in mind. And I use this slope, this perpendicular slope, for all calculations afterwards. So write the equation of perpendicular lines. Write an equation of a line perpendicular to y equals negative 3x minus 5 that contains negative 1/8. Well, my slope's negative 3. But when I read this, of the perpendicular line, it's going to be 1/3 because I take the opposite reciprocal. I flip the 3, which is 1/3, and take its opposite. So that's where it's a positive 1/3. Now I'm going to use that positive 1/3 in my calculations, and I'm still using 8 in for y, negative 1 in for x. But now keep in mind on this one, I'm not going to have you solve and go through, and somebody got a little lazy with his parentheses here. I'm done. I don't have to solve it. I mean, I can. It's going to be pretty ugly. It's going to be y minus 8 equal 1/3 x plus 1/3. This is where my fraction skills come in. I'm going to add 8, but I'm going to add 8 in form of thirds, which is 24 thirds. I'm going to add 24 thirds to both sides. So y is equal to 1/3 x plus 25 thirds if I wanted to put it in slope-intercept form. Okay? Now, generally, if it's going to get ugly like that, I'm just going to want to do one or the other. But remember, I wanted you to write an equation of a perpendicular line. I didn't tell you which form. This was perfectly fine right here to finish it out. Your turn. Go ahead, do B. Read the slope, okay? Get the stuff going on and see if you remember what we did on the previous problem. Again, what I said, previous problem. I got my slope, -1/2. Opposite is positive, -2. The opposite is 2. Its reciprocal is 1/2. But now, this is the y-intercept, 0, 3. There's a 0 there. So that's the y-intercept, so I can quickly be done. Or, if I didn't notice that, I could finish here and I'd be done with this. And then I'd just distribute and be okay. Now, write an equation of a line perpendicular to y equals -x plus 6 that contains -2/4. I want this equation for the slope, which is -1, and then take its opposite reciprocal. Well, which is just 1. Now I plug in 4 for y1 and -2 for x1, and that's what happens. And now I can be done, or I can solve for y after distributing. Distributing 1 is really easy. I love it. So we'll solve for y and add 4 to both sides. And I've got my slope-intercept form version of the equation. These two equations are the same as far as it's for the same line, but they don't look the same. One is point-slope form, the other is slope-intercept form. Last one, go ahead, it's your turn. Get her done. Okay, hopefully you turned me off and you practiced. This is 7, so it's 1/7. The opposite of that is -1/7. And we have my point-slope form. Remember, after I read the slope, I get rid of this equation. I don't want to deal with it anymore. So 2/3, or excuse me, 2, 3, not 2/3, goes in. 2 goes in for x1, 3 goes in for y1, and I get this equation. Since this 1/7 is going on, I could totally solve if I wanted to, but let's get that done. If I wanted to put it in point-slope form, I'm done. This is point-slope form. But if I wanted it in slope-intercept form, I got to distribute that -1/7. And that's going to be 2/7 on top, right? Because that's distributed, so it's a negative and a negative. Now I've got to get this in form of sevenths, which is 21/7. This is 21/7. I'm going to add to both sides. So I'm just going to put that in there, right? Because that's still 3. Everything else is popping in here the same. Sorry, my mouse skills are a little sloppy. But I'm going to add 21/7 over there. So now I got y equals -1/7 x. Somebody's got to erase that. -1/7 x plus 23/7. And this is slope-intercept form. Okay? Well, that's it. Those are the equations. That's what you're going to be asked to do on today's assignment. You will be doing a quiz on this very soon, so be ready to be able to write equations given a slope and a y-intercept, given a point and a slope, given 2 points, using point-slope form. Have a great day.